Hello, welcome back to the fabulous world of calculus. In this video, we're going to talk about linear approximations, which is really just using a tangent line to do something. And that something is approximate a function value. So let's look at the little picture about what it means to use a tangent line to approximate. So this picture has the tangent line at x equals a drawn in blue. If we want to approximate this, if we move to some other point that's near x equals a, and we use that value that is on the blue curve versus on the black curve, so on the tangent line, then we're using the linear approximation of this function to approximate the value of the function using the tangent line. Okay, great. One of the actions that I wanted to show you, or manipulations of this point-slope form of a line, is the tangent line looks like y minus f of a equals f prime of a times x minus a. And the way that our book and Newton-Alta rearrange that is they rearrange this to look like y equals f of a plus f prime of a times x minus a. So they call this the linear approximation or the tangent line. And when we use this tangent line to approximate a function value, then it's known as a linear approximation. Great. So the difference between a tangent line and a linear approximation is effectively what you're doing with that object. If you're using it to approximate a function value, then the tangent line is a linear approximation. Great. So let's go look at an example that I conveniently borrowed from Newton-Alta, where we're asked to use an appropriate linear approximation to estimate the square root of 16.07. Okay, so one of the things that we have to do is make our own function. So we have to create a function from nothing. So what I look at there as I see a function that we could use is y equals the square root of x. And when we do that, now we want to pick a base point so that we can be nearby when we evaluate at 16.07. So I'm going to pick the base point to be 16 because 16 is something I can take the square root in my head, and 16.07 is near, whatever near means. It's near 16, so it's a good base point. All right, so all that we need to do is then build a tangent line and use that tangent line to help us find this estimated value for 16.07. Great. So let's find the derivative here so we can go and find the slope of our tangent line. So dy dx, we use our power rule. Oops, my iPad screen went weird there for a second. But we got dy dx equals, let's see, the power rule says to take the exponent down, so the square root's the 1/2 exponent. Take the exponent that we had and subtract 1. So we get 1/2 x to the minus 1/2, which is the same as 1 over 2 times the square root of x. All right, so there's our derivative of the function square root x. Now we need to evaluate that at x equals 16 so that we get the slope of the tangent line, which is going to be our linear approximation at x equals 16. So we can evaluate dy dx, evaluated at x equals 16, and that just means plug in x equals 16. So I believe this is 1 over 2 times 4, which is 1/8. Okay, great. So there's our slope work. We've been able to get the slope for our tangent line, which means I think we can write down our tangent line equation now. So we can write down y minus, oh, well, we don't know what it is, but we know the square root function is our function, so we can put square root 16 there. We can resolve what that is in a second. And then this is equal to the slope, which was that derivative value, times x minus the base point, which is 16. So I think this is y minus 4 equals 1/8 times x minus 16. And so we could get this into the form that we looked at above in general, which is y equals 4 plus 1/8 times x minus 16. So the way that linear approximations work and are combined with tangent lines is that near x equals 16, f of x is approximately, oh, that's not something we named. I meant to say square root x is approximately equal to this tangent line. So the values that we get on that tangent line are approximately the square root values near x equals 16. So to go and answer our question all the way, to get all the way to the end, we just need to take and plug in x equals 16.07, plug in that to the tangent line. I'll abbreviate tan line, again, because it's fun and also saves us some time. So we get y equals 4 plus 1/8 times 16.07 minus 16, which is y equals 4 plus 1/8 times 0.07. We're asked to round to 3 decimal places, so I would go and use a calculator or Wolfram Alpha to go get that decimal of what is 1/8 times 0.07. And I've already done that and taken a little screenshot. So what is 0.07 times 1/8? It is 0.00875, which means we really want this to round to 3 decimal places as 0.009. Okay, so now we know that we have y is equal to 4 plus 0.009, which is 4.009. So that is our value that is approximately 16.07, the square root of. And you can use a calculator or Wolfram Alpha or something to see how far off that approximation is, but that's not what we were asked to do. We were just asked to use the appropriate linear approximation to find that estimate. I hope this was helpful. Have a wonderful rest of your day.